Yeah, thanks. It's great. I didn't realize I was going to be the first speaker today, so that's always fun. Um, my talk is going to be very high level, only 5 minutes, just talking about monitoring in general. Um, I applied to give a talk today without knowing what the general theme was going to be. And I was really excited about it because, oops, there we go. This is a part, really a key part of what my lab does is thinking about how to do monitoring. And so what a lot of you might be engaged with is monitoring different things that might be going on in the estuary. A lot of what my lab thinks about is how to actually monitor. So how do we think about not only what to monitor, but for how long should you monitor? What kind of approaches are best? What are the most cost-effective ways of going about monitoring? And so really thinking about some of these key questions of thinking about the design, really the kind of the theory behind monitoring. So that's a lot of the work we've been doing. How do we gain the maximum amount of information? And so you might have two approaches and one might be more cost effective in some way. We also have to think about information theory and how much information you're actually gathering from monitoring approaches. And then lastly, how do we combine disparate data sets? So I'll just talk about a few examples of this later on. But thinking about if you have different data sets, I think we're all very good at monitoring the thing that we care about, but how do we actually combine them together, I think is where we really need to go instead of just monitoring things individually. There'll probably be a bunch of maps like this today of basically some way to summarize a bunch of monitoring efforts in Great Bay. As we can see from the packet, which is really great, that the packets on the tables about the various monitoring programs. There's so much that is going on, and there's so many different people that are involved. There's just one summary of some of that compiled by PrEP of thinking about this is from the State of Estuaries report of thinking about all the different things we monitor collectively as a group. I think this is amazing, but I think we have to be really thoughtful about how we actually go about monitoring, where there's some things we should probably start monitoring, and there's some things that we maybe should stop monitoring, or maybe things that we should change how we actually monitor. And so that's where if we be thoughtful about the actual monitoring design, where it's very convenient to maybe monitor things in the same way that we always monitor them, but that might not actually be the most effective way going forward. And so when you think about monitoring design, this is really thinking about how do we consider what kind of information we can gather from these different programs, and thinking about how to do that in a cost-effective way. So questions like, well, how many years do I need to sample, monitor for until I can make, have some confidence on what the overall trend is going to be? Or how many sites should I be monitoring in Great Bay? And so we can use lots of different approaches here. So I try to use a laser pointer. Oh, nice. So we can use simulation or mechanistic-based models. This is where we actually build mathematical models, which are simplifications of the natural system, and then try to understand how these different variables interact with one another. And you can make some projections out to think about, well, how would you design the program given different constraints? And we can also do experiments with existing data, which Barbara Speaker will talk about next. Thinking about if you have existing data, how can you modify your monitoring program in some way to make that more? So yeah, really key part is monitoring design. The other really key part is thinking about how do we actually combine data. And so this is, I think, really the big challenge for us moving in the next 10 or 20 years, thinking about how to actually combine the data sources that we're all working on together instead of monitoring them in silos. And we can think about how to combine data sets themselves using various approaches going from mechanistic modeling, which I just talked about. Obviously, we can just do statistical approaches to think about how various pieces are correlated with one another. And then in the middle, you have things like structural equation modeling, which is a bit of a hybrid where you have some focus on mechanisms, but also thinking about how these things are correlated with one another. And so I think using this full spectrum of different ways to combine data sets will be really important moving forward. Because if you think about, if we want to monitor eelgrass, water quality, we need to combine these things together to understand what's going on. And so I think we're doing a lot of this right now using single variables. I would like to do more of this and ultimately have these mechanistic models that you can actually use for management and actually understanding, well, if we change one factor in this ecosystem, how's that going to affect everything else in that ecosystem as well? And the only way we can do that is understanding the mechanisms behind these systems. I will leave it there.